Okay, so we are going to be factoring out the GCF. GCF stands for greatest common factor. We're going to be factoring the greatest common factor. And so we're going to divide the greatest common factor out of our example. 5x squared minus 9. So first of all, we're going to look at the numbers 15 and 9. What's the biggest number that you can think of that divides both 15 and 9? So we're going to divide this one by 3, and we're going to divide this one by 3. Do we have another side of the equation so that we can divide 3 on the other side of the equation? Is there an equation at all? This is an expression. It doesn't have an equal sign. I am not dividing 3 on both sides of an equation. I am dividing 3, and it's not canceling out. It's factoring out, and it's going to go out in front, because it doesn't disappear. It just moves out in front. And so 15 divided by 3 is 5, and then I have the x squared. 3 divided by 9 is 3, and still negative. So do you see that if I distributed that, it would be the problem I started with? And so that's why I sometimes call this undistributing. We're doing the opposite of distributing. The mathematical term for it, though, is factoring. Five and 10. What's the biggest number that divides both 5 and 10? Now, do you see that they both have the same variable? They have a common factor that's a variable. This one has an m, and this one has an m. And so I'm going to factor out an m. Now, we haven't had our unit on exponents yet, so I don't know if you know how to factor exponents or what to do with that. So we had m squared over m. That's what we had, right? M squared, that's what m squared means. So m squared over m, one of these will cancel and one of these will be left. And so when we factor out in front, what's 5 divided by 5? 1, but we don't usually write the 1. And this m cancels one of those and 1 is left. That's what I was doing on the yellow paper. 10 divided by 5 is 2, and these m's cancel. If I distributed this number that's out in front, it would be equal to the one that I started with. Y'all ready to step it up? 8a squared b squared minus 12a b to the third power c squared. 8 and 12. What? Now, 2 divides both 8 and 12. But it is not the GCF because there's a bigger number that divides both 8 and 12. What's the GCF? Oh, wait, I wanted to do something before I did that. And so then we got to have all those exponents. Before I did that, I wanted to do what's called expand the exponents to help you understand a little better what's going to be going on with the exponents. We'll come back to the 4 in just a minute. Is it obvious why that would be called expand the exponents? So instead of writing a squared, I wrote a times a because that's what a squared means. Instead of b squared, I wrote b times b because that's what b squared means. So I expanded it all out. And now I'm going to be able to find my GCF. do you see that both of my terms have an A? So A is part of my GCF. Do you see that both of the terms have a B? Matter of fact, both of the terms have at least two B's, if not more. Do they both have a C? No. So 4AB squared is going to be my GCF. 8 divided by 4 is 2. This is going to cancel, this is going to cancel, this is going to cancel. What letter is left? 4 will go into 12 3 times. This is going to cancel, this is going to cancel, this is going to cancel. C squared is left. Next example. We're on 4, right? 6. W squared Z squared minus 9W3 third power Z plus 3W squared Z. So the best thing to do here is to start by expanding. Expand and then find your GCF. What's the biggest number that's going to divide 6, 9, and 3? This has a W, this has a W, this has a W, this has a W. This has at least 2 W's. This one has 3 W's. But I can't use 3 W's for my GCF because this only has 2. And if I use 3, then I would wind up with one down here in the denominator that didn't cancel out. And we don't want to have letters left over in the denominator. Do they all have a Z? So 3W squared Z is going to be my GCF. 3 goes into 6 2 times. Cancel, cancel, cancel. What letter is left? 3 goes into 9. Cancel, cancel, cancel. I have a W that's left. 3's cancel, W's cancel, W's cancel, Z's cancel. It all cancels. What does that mean? Well, canceling is actually dividing. What is 3 divided by 3? And what is W divided by W? Anything divided by itself is 1. So this polynomial divided by this polynomial, anything divided by itself is 1, not 0. There has to be a 1 there. Is there any number that is a GCF? I could divide it by 1, but if I divide it by 1, isn't it going to be exactly the same? So a GCF of 1 is pointless. Do they both have x's that I could factor out an x? But what we are doing with the factoring is we're doing a step on the road to solving polynomials. When we get to the step of solving polynomials, it's difficult to solve them if they start with a negative. So if it starts with a negative, we are going to factor out that negative. And so there's not another number, but I am going to factor out a -1 so that I don't start my binomial with a negative sign. And then what's going to come next is taking this part right here and solving it. The eventual end goal is to solve polynomials. It would scramble your brain if I tried to teach you all this factoring and solving all in one day. So we're going to get real good at factoring, and then we're going to add solving to it. X squared minus 2x plus 8. 4, 2, and 8. What divides 4, 2, and 8? Because it starts with a negative, I'm going to divide by a -2 so that I can factor out the negative. Do they all have an x? 2 of them has an x, but 1 doesn't. So I cannot factor out something, especially variables, unless they all have the same variable. So I'm going to factor out the 2 in front. 4 divided by 2 is 2, and the negatives cancel. 2 divided by 2 is 1, and the negatives cancel, and we don't usually write the 1. 8 divided by 2 is 4, and that's going to make a negative because I factored the -2 out in front. Okay. You think we can do that much? Because now we are going to look at a different pattern that's called the difference of two squares. Do you know what the word difference means in math? Subtraction. Difference means subtraction. Do you know what a perfect square number is? I have a chart for you. This chart is on the end of your notes for today in Cami. So why would these numbers be called perfect squares? 2 times 2 is 4. 3 times 3 is 9. 7 times 7 is 49. But do you know why they're called perfect squares and not perfect triangles? Do you know it actually has to do with squares? If I had a square that had a side of 2, what would the area be? 2 times 2 is 4. The area would be 4. That's the tie-in with an actual geometry square. If that's the side of the square, this is the area of the square. So there's a reason they're called perfect squares and not perfect circles. And so these numbers are perfect squares. And so what would the square root of 16 be? Because that's the number that you multiplied together to get the 16. What would the square root of 64 be? Because 8 times 8 is what you multiply together to get 64. Now, if you don't know your perfect square numbers, this chart is in your notes in Schoology. Okay, so the difference of two squares is going to be a special pattern that's going to come up over and over and over again, and so that's why we're going to memorize it right here starting today. Do you know why I would call that a binomial? It has two parts. Do you know why I would call it a difference? Do you know why I would call it a square? Because A is squared. And when I factor it, it always factors into this pattern. Now, when it's factored out, do I have squares anymore? No, because I took the square root. But remember, before I can use this pattern, you must always use, factor out the GCF first. Do you know what problem? I was on problem number 7. I lost my numbers. So, first, does it have a GCF? No. If it doesn't have a GCF, then is it a difference of two square pattern? Does it have a difference? Does it have a subtraction sign? Are there two of them? Are they perfect squares? If you say yes, 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 then you can use the difference of two squares. They are perfect squares because the square root of 9 is 3. The square root of 25 is 5. What about this? Well, x squared means x got multiplied by itself. Did it get multiplied by itself? Isn't that what a square root does, is find the numbers that got multiplied by itself? And so the square root of x squared is just x. If it is the difference of two squares, yes, it has a negative sign. Yes, there are two of them. Yes, they are perfect squares. Then it will factor into this plus minus pattern. The square root of 9 is 3, and it has an x. The square root of 25 is 5. Sorry about that. I made a sign mistake there. I had to fix it. So, these are called factors. Factors are numbers, or binomials in this case, that multiply together. If I multiply them together, I would get the original problem back. 3x plus 5, 3x minus 5. 3 times 3 is 9x squared. Are we getting pretty good at the box problems? The only trouble is trying to get them typed in the computer, right? Now, what happens to these two terms right here? What happens when I have a negative 15 and a positive 15? These cancel out. Is that the problem that I started with? So I am breaking this problem down to the factors. I'm breaking this problem down to what I need on the box to make it equal to that when I multiply it out. Step 1. GCF first. Does it have a GCF? No. Step 2. Does it fit the pattern? Does it have a different sign? Does it have perfect square? Oh, are there two of them? Are they perfect squares? Then it will factor into this plus minus pattern. 2x, 2x, with this plus minus pattern. You don't have to check every problem. I'm going to check several. So you see that when I do multiply this together, 2x minus 2x minus x squared. What happens to these two terms right here? Positive 2x, negative 2x cancel each other out. And so I have 4 minus x squared left. Was that what I started with? X squared minus 2. GCF first. What is the GCF here? And so the 2 factors out in front, 25x squared minus 1. Now, I'm not looking at the 2. The 2 is just going to sit out there in front. Looking at the 25, the x squared, and the 1. Are they perfect squares? Oh, what about 1? Do you know what the square root of 1 is? Because 1 times 1 is 1. So, is there a minus sign? In the parentheses, are there 2 of them? Are they perfect squares? If you say yes, 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 then it's going to factor into this plus minus pattern. If I used a box problem and multiplied that out and then distributed the 2, it would be equal to the problem that I started with. The first step is GCF. 2 divides this, 2 divides this. Do you see that they both have a y? Do they both have an x? So 2y, so the 2's are going to cancel, the y's are going to cancel. The y's are going to cancel. 2 goes into 162. In the parentheses, do I have a difference? Do I have 2? Are they perfect squares? Now, this part that I'm doing right here, I'm doing that to show you where I'm getting the perfect squares from. Certainly after you do a few of these, this part should be mental math. You shouldn't have to write it down on your paper. But I'm just writing it down to show you where I'm getting my numbers from. So this is going to be x times x to equal to x squared. 9 times 9 to equal an 81. The negative sign is going to make it equal to negative 1. The positive negative pattern is going to make it cancel out those middle terms if I did a box problem. Is there a GCF? No. So, is it going to fit my pattern? There's 3 conditions. Does it have a subtraction sign? Are there 2 of them? Is it a perfect square? Do you know that the square root of 49 is 7? Is there a negative sign? No. Is there a GCF? No. This does not factor. The only GCF there is GCF of 1. When you divide by 1, it doesn't change anything. Do you remember the name of something that you can only be divided by itself in 1? Have you heard of that word before? Prime is a number that can only be divided by itself in 1. This isn't a prime number. This is a prime polynomial. It can only be divided by itself in 1. It does not fit our pattern, and so it cannot be factored. The ones that cannot be factored are going to be a little bit more difficult when we get to the solving part. So, there is no GCF. I told you that if it starts with a negative, you can factor out a negative. You can also do this. Now, does it start with a negative? No, it starts with a 9 now. And so, does it fit our 3 conditions? Does it have a subtraction sign? Are there 2 terms, called a binomial, by the way? Are they perfect? And so this will factor. So this will be 3 times 3 is 9, and x times x is x squared. Let's go ahead and check this one. 3 plus x, 3 minus x. What happens to these middle terms? Cancels out. And so this is 9 minus x squared. Is that what we started with? And so this will check out. So do you think you can find the GCF and factor it out? Can you find the difference of 2 square pattern and factor it out? If you need these table of perfect squares to help you out, that can be found in your notes that are in the Friday folder. I don't know why I always lose my mouse.